All right, so thank you again for being here today. I'd like to welcome all of you from CNMI, from Guam, and from American Samoa. So today is the second of 3 collection systems focused webinars. So today we'll be focusing on pumps and force mains, as you can see on the title there. And then in our next session, we'll be covering collection system maintenance. And in the previous webinar on collection systems, we were looking more at the collection system itself as far as pipes and manholes and appurtenances. So if you missed that one, you can watch the recording and you can see the slides, all of those things. But wanted to let you know that this is the second in a series of 3 on collection systems. So for today, your trainers are going to be myself. My name is Dawn Nall, and I am an engineer at the Southwest Environmental Finance Center. And then I have Valeria helping me. And if you have questions today, things aren't working, or maybe you missed something, or just a question comes up, please reach out to Valeria in the chat and she can help you with any of those technical issues or things like that. And then Valeria will also be helping me kind of monitor questions that come in so we can make sure that we get all of your questions answered today. So if you aren't familiar with us, if this is your first time tuning in, we are with the Southwest Environmental Finance Center. We are a part of the University of New Mexico in the School of Engineering, and we are funded through resources from the Environmental Protection Agency at the headquarters level. So we do offer training in all 50 states and obviously in the territories and in the tribal nations as well. So thank you again for being here. And we're doing this series specifically for you guys in the territory. So make sure that you ask questions, that you anything that would help you, make sure that you let us know. If you're not familiar with Zoom, we just wanted to give you a quick snapshot. And this will probably be in every one of these presentations, so it'll probably get old pretty quick, but in case we have folks that are new to Zoom, you should have a control bar on your screen. And if you don't, you might slide your mouse down to the bottom of your screen and see if it pops up, or possibly the top of your screen if you're on a tablet. So you should have a toolbar that looks like what's on our screen here. And I think the most important things for you to be aware of are probably the button, the box number 5, the chat box. That's where you can type questions in, you can communicate with us, you can help answer questions. We will have some practice questions today at the end of the session that you can participate in as well, but that will pop up separately on your screen. And so all of those buttons do individual things. If you've got questions about any of them, let Valeria know, but probably the most important one to be familiar with is that chat button. So the next thing I wanted to talk to you about today is that this series is designed to supplement and to reinforce the ABC need to know criteria for specifically the wastewater operator level 1 and level 2 exams. We will cover some higher level topics, but we're primarily focused on level 1 and 2. We won't follow exactly the order listed in the need to knows, but we are covering the majority of the criteria in there. So if you're not familiar with those need to knows, you should be. You should print them out, you should look at them, you should get familiar with them before you take your test. And that way you know areas to study and where to focus, things that maybe you're strong in and things that maybe you're less strong in, where to focus your time studying and attending these series. And so as part of that, the WPI has essentially 3 wastewater operator certification tracks, and we're going to be focusing on wastewater collection and wastewater treatment. So you can see what those need to knows look like. Very similar. The differences are in your titles here, wastewater treatment and wastewater collection. So make sure that you are familiar with those and you know which ones you should be looking at for which test you're taking. And since we are focusing on the collection systems right now, that doesn't mean that if you're looking to take your treatment test that you should just tune out. There's a lot of overlap between the materials on the test, and so today's information should be valuable to you as well. and not just for test taking, but in your day-to-day operations, really understanding both sides of operations, treatment and collection systems is helpful and important. Also, we wanted to make sure that you're aware of the resources that you can use for studying. You can get these from Amazon or directly from the manufacturer or supplier. So there is there are a couple of resources. So you can see here, these you can get from like Amazon, the WEF guidebooks, the study books, or you can use the SAC State books. We talk about SAC State books a lot. So this is what it looks like. There's different volumes, different versions. Also, I think that each of the territories have been supplied with a copy of the SAC State books, whether they're at your local treatment buildings or in a local library on island. Those should be available for you too. So I wanted to make sure that you're aware of those study materials and that they are available. And if you have a need for more of them, you can kind of let us know, and we'll see what we can do to see if we can get more copies out to you guys. So the collection operator exam content, when you look at the level 1 or the level 2 exam, in that need to know, you see these tables. And so we're focusing today right here on this 18 question section. And then on the level 2, it's 15 questions. So important stuff, important information to know and understand for your test, as well as your, day-to-day jobs. And then for the treatment operator, even though it doesn't specifically talk about lift stations, we're going to spend a fair amount of time today talking about equipment. So equipment evaluation and maintenance, equipment operation. So you can see on the level 1 exam that that's 50 of your 100 questions. And on your level 2 exam, that's 45 of your 100 questions. So like I said, a lot of overlap, a lot of relevant material for either test today. So here is our schedule for the sessions that we're offering to cover different content that could be on your operator certification exam. And we did start back in June. So where we're at today, right here, almost halfway through the first half of the year, or of the sessions. So there are 26 sessions total. And this schedule shows you the remainder of this year, but they will be going all the way through the middle of 2026. And as you're probably aware by now, there will be different trainers. This is my first session to be involved in for this particular group, but this will not be the last time that you get to see my happy face. So I will be doing more after the beginning of 2026. So I work with all of the folks that have trained you so far, with Shannon and with James and with AJ. So all of those folks are part of our staff, and I work with them on a daily basis. So one last reminder that I wanted to give you is this one, and it's important. I guess it's not the last one, but it's an important one. We do get a lot of questions about this after every session. We are putting every webinar recording, every handout, every bit of information that we might share with you on our website. So if you miss a session and you want to catch the recording, or you want to refresh yourself, in a few weeks or a few months on a particular session, you can go and watch the recording. And all of the handouts that we have, we will share on the site as well. Also, the schedule is here. So if you don't remember what date a certain session's on, you can check it out. So make sure that you're familiar with our website, and that you know that if you need anything for any of these sessions, that you can get it right here on our website. And then the final reminder is that if you are attending one of these sessions in a group, if you're at CNMI, or if you're at Guam and you're in the conference room together, make sure that you sign in, and then the facilitator at your location forwards us the sign-in sheets. and we are keeping track of your attendance hours so that you get your credits for attending these sessions. So you're getting your continuing education credits by signing in on this sheet. If you don't sign in on the sheet, we don't have a good way to know that you were there. So we can't, give you the credit. So it's super important that you sign in on the sheet, and then we can give you that credit. So I think that's it for all of the introductory kind of reminder stuff. We're going to focus today on our collection systems, our pumps, and our force mains. So here are the things that I will be covering today. We're going to look at lift stations and lots of the different things about lift stations. What do they do? What types are there? What are the components in a lift station? And then a bit on operations and maintenance. Then we'll focus specifically on the pumps that are in lift stations, the types that you might find in a lift station, the operations of those pumps, and then pump curves. And what do you need to know about a pump curve? And how do you read those dang things? So, and then finally, we'll take a look at force mains, and a little bit of need to know about force mains. So before I jump in, I'm gonna give you guys a chance, if you have any questions on kind of generalities, to go ahead and get those into the chat now. And then if not, we will dig right into lift stations. All right, I'm not seeing anything immediate. If you're typing, please feel free to keep typing and we'll get right to your question, but I don't want to keep everyone waiting too long. So we are going to move right into our content for today. So we're going to start by talking about lift stations. So the first thing that every kind of training book or anything like that talks about is the purpose of a lift station. So I would guess that you guys have a pretty good idea of what the purpose of a lift station is. So if you feel like you have a good idea of what a lift station is, would you go ahead and chat it in? Or I think you can unmute and chat in. I'm not sure about the settings, but maybe you can unmute and tell me what the purpose of a lift station is. All right. I'm not sure if it's that you can't unmute or that you're just not excited about telling me what the purpose of a lift station is this early in the morning, but the purpose of a lift station, I've got one. The purpose of a lift station is to lift sewer to the next station due to elevation. So great, thank you. I don't know who at the CUC Wastewater group type that in, but I appreciate the effort and for the participation. So the way that I wrote it out, the way that some of the training books describe it is pretty close to what you typed out there, raising wastewater from lower to higher elevation, right? So we're lifting water, thus the name, lift station. Sometimes we say pump station because we are pumping water too. We're using pumps to move the water into the force mains. But for the sake of clarity, I think that we prefer to use lift stations for wastewater and pump stations for drinking water. And that way we know a bit more about what it is we're pumping and the reason that we're pumping it. So lift stations, primarily, we're raising water from one elevation to a higher elevation. So I've got another commenter to convey sewage to a treatment plant. Yep, so oftentimes right before the treatment plant, there's a lift station. And that's typically because our collection system is gravity. And that means that it's running downhill regardless of the terrain. So it can get pretty deep. And then we have to lift that water up into the headworks of the treatment plant, or whatever our first stage of treatment is. And then finally, after that water is pumped, it goes into that force main. After the force main, gravity takes back over. So if you pump into the next manhole, then it returns to gravity flow. So just the last note there is that the purpose is to raise the elevation, that it uses pumps, and then it returns to gravity. Okay, so where would we find lift stations? Where do we put lift stations? Well, anywhere that the terrain would require deep excavation for gravity. I have a note here that backhoes are limited to around 30 feet of depth. And that's a pretty deep trench, right? And then you think about the slope of that trench and your trench box and all of the things that go into a trench that's that deep. It can be very expensive to excavate that. So if the cost of excavation gets too high, or if you're in an area where there's significant soil instability or soil that's really hard to excavate. So if you have really rocky soil, where it's, maybe you're having to blast instead of dig, you may want to pump around that area. Or if you have a high groundwater table, and I know that you guys experience that in some of the locations on island where your water table is shallow, so you can't put gravity sewer below the water table with much with ease. So we would want to have a pump station or a lift station there. Or where it might be an economical solution for your current flow levels. So if you have really low flow, or you're dealing with your gravity pipes having to be sloped too steep, anything like that, that might be a place where you would have a lift station. So the first one's kind of obvious, right? The pipe gets too deep in the ground, we have to lift the water up and then return back to gravity again. But these other ones maybe aren't quite as obvious, so just things to be aware of as to where we might locate lift stations when when the engineers are designing it, or when you're thinking about where the wastewater collection is when you need lift stations. And then lift stations, the design goals, the goal is obviously to move the wastewater with maximum efficiency. We don't want to be spending money to pump water in a way that's wasting a lot of energy, a way that's wasting a lot of pipe diameter, things like that. So we want it to have, when we're designing that lift station, we want to design it to have maximum efficiency. So we have to understand things like flow rate, how much flow is entering that lift station, how many homes or businesses or other users are connected to that particular section. So the goal there is to maximize efficiency. So your pumps have to be selected to minimize surges. So if you think about it, the pump kicks on and the water flows, and then the pump kicks off and there's no flow, and then the pump kicks on and it flows. And so if we are doing that in a fashion where it's kind of a on off, and we have the surge and nothing, we want to try and minimize that when we're designing our lift stations, so that the flow is nearly as constant as possible. Not that we want our pumps to run continuously, but we want to think about how that design is affecting that surge issue. And then we also want it to blend in. We probably don't want to advertise too much that there's a lift station here. Come and graffiti it, or come and try and climb in it, or, any of those things that we might deal with. But also, if there are homes nearby, and you guys all have beautiful terrain and scenery, you want it to not distract from that. So, those are things that you also take into mind when you're designing your lift station. Is how close is it to, a home or a structure, or what if there's odor issues or noise issues, things like that. So just a few notes on the lift station design and some of the goals that your engineers should keep in mind when they're designing the lift stations. So the next thing I want to talk about is the different types of lift stations. And almost always, if you Google wastewater lift station, you're going to read about two types of lift stations. And I think you guys are most familiar with the wet well, but there's also a dry well situation. So they're different in the fact that the wet well is a single chamber and the dry well has two chambers. So if you think about it kind of as rooms, in the wet well, everything's in one room, right, in that single chamber. In a dry well, there are two rooms or two chambers. One has the wastewater in it, and the other has all of the mechanical stuff in it, your pumps, your motors, your valves, your controls. So there's some advantages and disadvantages to both. And oftentimes the cost is the reason that you were more familiar with wet wells, with wet well lift stations, because they are less expensive to build. However, maintenance can be more problematic. You guys can't see the pumps when they're underwater in your lift station. Our wastewater entering our lift stations isn't very clear, isn't quite see-through. So it's hard to know what's going on down there in the bottom of the wet well. So maintenance can be a bit more problematic. Also, wet wells can be confined spaces. They can contain toxic gases. And so, entering or pulling a pump, you have to be aware of confined space entry and concerns like that. With the dry well, your machinery, all of your mechanical equipment is in that dry space, that dry room. So oftentimes the larger lift stations in big cities or areas where you have really high flow rates, maybe industrial type situations, you might have a dry well lift station, because that way you can get to those pumps, you can get to those valves with ease. And you're still looking at confined space, and of course you've got sewage on one side, so there still could be toxic gas issues, still those safety issues to be aware of with a dry well, but possibly easier to work on your pumps because you don't have to pull them out of the wet well. But like I said, advantages and disadvantages. The important thing is that you're aware that there are different kinds, and you're aware of what it means. So if you're looking at, you're getting ready to take a test, you go to the test room, and one of the questions is, name the types of lift stations. Now there's a wet well and a dry well. So those are just a couple of things to be familiar with there. And I wanted to make sure that everything that we're talking about today is mostly contained in the slides, so that if you go back and review them, it's not just a picture of a wet well and a picture of a dry well, but there's some notes here. So I did kind of take out pictures for the sake of having more words, which usually I don't like to do. But for this case, I think it's really helpful to be able to go back and review. Just having the picture doesn't maybe remind you or tell you as much as the words on the slide do. So I do encourage you to look at any of those study books out there, and they're going to have pictures of a wet well and a dry well lift station, so you can refer to them and get familiar with them and understand, visually a bit more what the differences between the two are. So we're going to kind of focus on wet well lift stations for the remainder of the time, because that's mostly what you're going to encounter. And the types of things that go on in a wet well lift station are the same as a dry well. It's just that the equipment might be oriented differently or located in a different place. So what I do have for pictures and things are going to be wet well lift stations. So if we take a look at a lift station, there are lots of parts and pieces in a lift station. And when you're thinking about taking the test, you want to make sure that you're familiar with the different components of a lift station. So I've listed out all of the components here, not all of the components, but the major components here. And we're going to kind of review each one in these next couple of slides in a little bit more detail. But kind of want to point out a couple of things here. So your lift station is going to be in some type of a basin, right? The dry well or wet well. This is a wet well where the water is inside of this structure, and the pump is inside of this structure. So you've got water coming in someplace, and in this case, they have this anti-splash tee. May or may not be the case in your lift station. All it does is allow the water to flow down to the bottom of the lift station so that it's not like a waterfall and creating all of that splash and releasing all of that odor. But you have water coming in somewhere. You have a pump. That pump is going to pump the water out somewhere. And then you have other components that allow you to access the pump, to control the pump, and to vent any gases. So, this should be a real familiar picture to you. And your study books will have pictures similar to this, not exactly like this. I borrowed this from a particular manufacturer's website. But you can Google lift station pictures, lift station schematics, and you will get something pretty similar over and over and over again. That was not supposed to happen, sorry. So let's take a look at these components in a bit more detail. So the first thing in the lift station, probably the most important component is the pump. And the pump depends on the depth of the lift station and the type of fluid that you're pumping. But in the case of wastewater, you're going to have probably just one of two types of pumps. And we're going to talk about that a bit more later in depth in these slides. And then your wet well or your basin, they're typically concrete. Sometimes they're metal, sometimes they're fiberglass. So just be aware that if they're only concrete in your wastewater system, they do exist in other, other types of materials. So again, something to be aware of for the test, because not everywhere are they concrete all of the time. They might be metal or they might be fiberglass, but typically, most commonly concrete. The size for the basin, well, it needs to be not too small so the pumps don't cycle too often, and not too large so the wastewater isn't sitting there for hours and hours and hours and it can go septic. We definitely don't want septic water to be pumping through our, and into our manholes and then to our treatment plant. So the size is based on the amount of flow predicted, planned to enter that lift station. And that depends on how many homes are connected to that piece of collection pipe, how many businesses, those kinds of things. So flow rate dependent is how it's sized. Other lift station components, your hardware. So this could be a ladder, it could be a handle, it could be any other, the lid, anything like that around your lift station. What's important for your hardware is that it should be corrosion resistant, right? Wastewater can be pretty corrosive. So it should be a corrosion resistant material. I've seen some manholes with the old metal bracket type steps where it's just kind of a U shape that's, drilled into the side of the lift station. And I wouldn't put my foot on that thing for all the money in the world, because I know that that metal is rusted through almost. And as soon as you put weight on it, it's going to snap off. You guys have probably seen those too, so not corrosion resistant, those old ladders that were drilled into the side of the lift station. So, I encourage you to avoid using those if you're not certain about their stability. And then some lift stations do have a bar rack or a bar screen. And this is where you're screening your wastewater before it enters the lift station so that large debris doesn't get in your pump and clog it up. So your rags, your pieces of, wood, the Toy Story toys, you guys have seen it all, I'm sure, if you've ever cleaned a bar screen. Sometimes at our lift stations, we have some type of a screen where the water is entering, and that has to be cleaned regularly. Otherwise, they can prevent flow from entering the way that it was designed to. You can have an overflow, you can have a backup, all those kind of negative things we don't want to have happen in our lift stations. And then the last component on this slide is your electrical system. Of course, pumps have to have some type of energy to run, and typically it's electricity. Sometimes, we might have different types, but it might be a generator, but it's usually coming from your electrical grid. And the pumps in lift stations, again, this is typically are 3-phase pumps. Sometimes they're single phase. If they're super small, or if you don't have reliable 3-phase power in the area where the lift station is at. And I'm not going to go into great detail about electricity and the differences between single phase and 3-phase. but it's a difference in your voltage. And so just be aware for the exam that typically your electrical systems at your at your lift stations, I keep saying pump stations when I told you guys not to, so have to get it under control here, right? But at your lift stations, your electrical systems are typically 3-phase. And then oftentimes at your lift stations, you're going to have a generator right there on site, so that if the power fails, you have the ability to run those pumps. Because when the power fails, that doesn't necessarily mean that the wastewater stops flowing, does it? So people are still flushing toilets and washing dishes and maybe showering and all of those things, even when there's power failure. I apologize, guys. Those aren't supposed to be popping up. But I don't think I can do anything about it at this point in time. And if you don't have a generator right there on site, you probably have transfer switch capabilities, so that you can bring a portable generator to the site and connect it to that transfer switch, so you don't have to do any wiring connections, but that you can just connect it straight to plug it in and do that transfer, use that transfer switch to say that now you're powering it from a generator and not from your electrical grid. More lift station components. Typically a lift station is going to have an alarm, maybe multiple alarms for high level to avoid overflow. The alarms can be visible, they can be audible, meaning it might be a flashing light, it might be a siren sound, it might be some type of buzzing, or it can be part of your control system if you have SCADA, and you can get a notification at your control center that there's an alarm happening, or you can have all of the above for alarms. And then your motor control center or your pump controls, these are your HOA switches, and your HOA is not your homeowner association. And if you don't know what HOA is, you need to get familiar with it for the test, but it's hand-off auto, right? So you can tell your pump essentially how you want it to run. You want it to run with you controlling it by hand? Is it off, or do you want it to run automatically based on your level controllers? Your pump starters might be in your motor control center. Your alarms might be in your motor control center. If you have lead lag pumps, meaning that you have more than one pump in the lift station and they're set to operate, that if one pump cannot keep up with the flow, a second comes on, those controls might be there in that motor control center. Any type of controls that you have are probably in your motor control center. Your electrical, control box, one of those like gray boxes that typically we try to keep locked, so that they can't be messed with if someone were to, come into your lift station and have ill intent. So, those control boxes, you guys are probably familiar with. And then of course our force mains, we're going to talk about these a little bit more later, but this is where your flow leaves the pump. This is your discharge line, and this flow is under pressure. So this is one of the few places in our wastewater collection system where the pipe is under pressure. The water is under pressure. It's being pushed by the pump, not flowing downhill by gravity. And so pressure, a system that's under pressure has different issues than gravity pipes. So we'll talk about that a bit more later. And then your pump controls or your level controls. This is what tells your pump when to turn on and turn off. It is based on the water level in the wet well itself. So there are different types of pump controls out there. And the most common type, and I think what you guys all have, are floats that float in the water. And whenever the water gets high enough, the float lifts up and it's not hanging on a cord anymore. Now the cord's, all the pressure's been taken off. And so when the pressure's taken off, it says, oh, the water's here now. So something can happen. It can turn on or it can turn off when the float hangs again. One of the issues with floats is that they can stick in grease. Debris can mess with them. You know, they can have issues with debris in the water kind of making them get stuck against the wall or not work correctly. So you guys are probably very familiar with the floats and some of the issues that come with them. And then there are other types that you should be familiar with. So we have probes or electrode controllers, and they utilize electrode probes or a lead. It's an open circuit, like an open electrical circuit, until the water level rises. And when both electrodes get wet, it sends a current, which causes the control circuit on the pump to turn on. And then when the water level drops, the probe is exposed, the circuit's open, and the pump shuts off. And again, this type of level control can have problems caused by grease and caused by rags. And then there's pneumatic controllers or bubblers. The pneumatic controllers work by sensing the pressure required to force air bubbles out of a tube located near the bottom of the wet well. So when the wet well is full, it takes more pressure to push those bubbles all the way to the top than if the wet well is empty, right, or low. I guess we don't really have empty wet wells, but when the levels get low. So it sets you have a set point for the pumps based on the pressure. Bubblers rely on an air pump, and you know, if you have a fish tank aquarium, you probably have an air pump in it. You can kind of think of that kind of an air pump to provide air so that the pressure can be measured as the bubbles are forced out of that tube. If the tube becomes clogged by rags or grease, or if the air pump fails, then the system stops working. So there's some, you know, possible issues there. Then the next type is mercury float switches. Mercury float switches are one of the most common types in lift stations. They consist of a float that contains a sealed chamber. It has 2 electrodes and a small amount of mercury. When the float's when the float's in one position, like vertical, the mercury is pulled away from the electrodes and the circuit opens. But when that float tilts and the mercury gets between them, then it closes the circuit and says that the pump should come on. And then pressure transducers, these are submerged. The pressure is created by the head, the pressure from the water level, and it's pushing on this flexible membrane, and that's converted to an electrical signal. And then finally, ultrasonic transducers. There's an ultrasonic pulse that hits the water from the top, from the surface, and bounces back. And however long it takes that pulse to go down and back is what's used to determine the depth of the water. So different types of level controls that you should be familiar with. The next components we're going to talk about, your valves. You typically have a couple of kinds of valves in a lift station. You have your isolation valves. These can be gate, plug, or knife valves. They're used to service your pump. So if you need to pull your pump, you would close your isolation valves and pull your pump. They should not be used for throttling. Throttling valves in lift stations can create all kinds of problems, and so it's discouraged. I know that sometimes we do it anyway, sometimes we have to do it, but if you're throttling a valve, it probably means that you got a bigger issue, and something should be changed. The pump, should maybe be changed because the flow rate's changed, anything like that. We typically see gate valves here. Plug valves have a restriction that can be clogged more easily, but sometimes there are plug valves or knife valves used for isolation. And then check valves. Of course, we have check valves, and they're swing or ball check valves. It prevents backflow, so the pump turns on and water's in that pipe. And then when it turns off, you have a check valve. So the water's not flowing back into your pump station from where you were trying to get it to go to. If your check valves are leaking, then your pumps have to work longer. They have to work harder. So you want your check valves to be operational and to work the way they're intended. And then other components, your wet well cover, your lid, those can be fiberglass or steel. access frames and hatches. These are your kind of access doors. They're typically aluminum. Your removal system to pull your pumps, the guide rails, and the vent that allows, you know, the gases to escape from the lift station. The last little thing here to note about your pump controls is that your water is, of course, flowing into the pump station, into the wet well, and the water level is rising, rising, rising. And then once the water reaches that first set point, the first pump will turn on, and the water level should start to decrease. However, sometimes the water level is not decreasing fast enough, or it's continuing to increase. That's where we would have a lead lag pump. So if you have lead lag pumps, that's designed for lift stations that may have variable amounts of water coming into them at certain times of day, because maybe there's a manufacturing plant or you know, things that can cause the flow to vary throughout the day. And so sometimes you would have to turn the second pump on to cause the level to decrease. Not all lift stations have that lead lag scenario. Some are just on off, but something to be familiar with and aware of. Once the water is being pumped out faster than it enters, the level starts to decrease and eventually reaches a low level set point, and that turns the pump or the lead lag, both pumps turn off at the same time. They can be set in different ways, but this is kind of a general operations of how the lift station should work. Next thing we're going to cover is lift station maintenance. So things to be aware of in your lift station: grit. You have grit in all wastewater systems. There's grit. You guys have you know, sand and things that get into your system. And it can lead to reduced flow to your pumps. It can lead to the loss of your wet well capacity. You can imagine if you've got a foot of sand in the bottom of your wet well, that now you have a foot less water, right? Because it's always sand. So your pumps are running more than they should be because your volume is being consumed by your grit instead of by your water. Grease and scum. You know, we need to try to avoid grease getting into our system, but it's inevitable. You will have some. It can cause odors. It impairs the functioning of equipment. To remove it, you can remove it manually, or you can remove it with chemical or biological treatment for fog. Fogs is fats, oils, and greases. Odor control, of course, it can get stinky at times around a lift station. And to minimize, you know, odors, we want to minimize wet well turbulence. But if it's a lift station that has a big depth and there's a deep drop, a lot of you know, turbulence can be caused. You can treat the odor with scrubbers or with biofilters that are on the top of your lift station, or you can add chemicals such as chlorine or hydrogen peroxide or oxygen. But if you're using chemicals, those have to be monitored closely. So when we're thinking about lift station maintenance, things that we need to do daily, monthly, annually, daily, of course, we want to inspect them. We want to record the flow and the runtime. If it's a lift station that's not got a high flow rate, that could maybe be moved to weekly instead of daily. Monthly, we want to do things like can check our controls, our gauges, our alarms, make sure they're all working the way that we expect them to. We might want to check our motor amperage and make sure that the motor on the pump is what we think it should be. It's not showing any wear and tear. Annually, we want to clean and inspect. We want to check the pumps and the motors. We want to check that the valves are operational. And then grit removal is kind of on an as-needed basis. Last thing about lift stations are safety hazards. Lift stations do have several safety issues. So they are a confined space. They can have hazardous atmospheres. It can be, you know, even deadly, the gases that are in a lift station. I mentioned the ladders being slippery or even not stable. There's mechanical moving parts. There's electrical hazards. Of course, insects, snakes, rodents, they like to hang out in lift stations. Infections and diseases can always be a concern when you're working in wastewater. If they have any kind of inadequate drainage around your valves, in your valve boxes, and, you know, potential drowning. So there is a future session on safety, and we want you guys to, you know, definitely tune in, but we want you to know that when you're working with lift stations, you should be working in pairs You should never be out there by yourself, opening a lift station hatch or pulling a pump or any of those, situations. So you should always be working in pairs. You should use radio communication for entry into a lift station. You should definitely understand how to use your gas detectors. You should understand lockout, tagout procedures, all of those kinds of things. And if any of these words sound weird to you or foreign, definitely make sure you're tuning into our safety session at the end of the month. So next we're going to take a look at lift station pumps. So lift station pumps, these are just a few quick facts I wanted to throw out before we get into the kind of details of the pumps. So here, lift station pumps, wastewater systems are usually very large energy consumers. In any community, a wastewater plant is one of the highest users of electricity of anything. Other manufacturing facilities, obviously houses. So pumps typically account for the second largest energy use for wastewater systems. Your aeration equipment is usually the largest energy user, but it depends on how many pumps you have and how big the pumps are. So it's important to operate and maintain your pumps to keep your energy costs down. And when we're thinking about lift station pumps, centrifugal pumps are the most common for lift stations. But we're going to talk about two kinds here in just a minute, but centrifugal pumps are the most common. And as I mentioned with lift stations, safety here, anytime you're working on a pump, you need a lockout tagout procedure to make sure that the pump's not still energized, but there's no risk of you being, electrocuted or shocked. And then your pumps are rated by the flow that they produce and the pressure that they must work against. So two things there about how pumps are sized and rated, the flow that you need and the pressure that they're working against. So as I mentioned, there's two types of pumps that your need to knows for your test state. So for the level 1 and level 2 test, it says that you need to be able to inspect, maintain, and operate centrifugal and positive displacement pumps. So that's what we're going to spend the rest of our time on. So positive displacement pumps, they're low flow, high pressure. I have a few examples of the kinds of pumps here. They provide a constant flow rate regardless of the discharge pressure. So sometimes they're used in lift stations and smaller lift stations, but they're not nearly as common as centrifugal. But sometimes you will see a screw pump in a lift station. But your centrifugal pumps are where you have typically more of a high flow, a low pressure. These are your booster pumps, typically your primary service pumps. And your flow changes when the pressure changes. So you can get different flow rates depending on the pressure that you're pumping against. And again, these are the most common type in lift stations. So we're going to look at the positive displacement pumps just real quick so that you're familiar with them. Again, they move a set volume of fluid in each cycle, so it's constant flow rate, but they cannot operate against a closed discharge valve. So different types of pumps mentioned here. I said a screw pump. You're probably familiar with a diaphragm pump if you've ever had a chemical metering pump. A rotary pump is what's shown in this picture, where you've got gears moving liquid through the pump, and then a piston. You guys are probably familiar with pistons, but they're like pushing water, and then the check valve closes and the piston goes back and the check valve opens and it pushes water. So that's a piston type pump. So those are all positive displacement type pumps, and you should be familiar with them. But the more common type is your centrifugal pump. So centrifugal pumps use some type of centrifugal force, which is moving something away from the center of a moving circle to move the fluid. So if you guys have ever been on like an amusement park ride, or even like the merry-go-rounds that we used to have on playgrounds when we were kids, and it's moving in a circle and you feel like it's trying to throw you off of it or throw you out, that's exactly what a centrifugal pump does, right? The impeller spins to move the water. It's taking the water from the middle and throwing it out to the edges of the impeller to move the water. And as that water moves out, it's moving faster and it creates a suction to bring more water into the pump. And there are a couple of different types of impellers. There are opened and closed impellers. Closed impellers have a housing around this inner part, and we typically don't use those in wastewater because they can clog so easily. So typically open impellers are what we find in wastewater. And your centrifugal pump can sit horizontally or vertically. You see them horizontally in the treatment plants, but we see them vertically in our wastewater lift stations because that way the wet well doesn't have to be wide enough for the whole pump and motor to sit down this way. It can sit this way because they're going to be deep anyway. So typically oriented vertically in a lift station. So some common components in centrifugal pumps, just mentioned the impeller that moves the fluid, the shaft, that's what spins the impeller, the bearings, that's what holds the shaft in place and allows it to spin as freely as possible, decreasing friction. The pump casing or housing, that's what's kind of around the outside of it. The volute, that's where the water is collected and it directs the flow of the water as it enters and leaves that impeller. And then of course your suction and your discharge piping. In lift stations, you don't have a lot of suction piping. You're sucking right into that pump. So it's not like in the plant where you might have a long pipe that comes into the pump and then a long pipe that exits. So there's not a lot of suction piping in a lift station, but there is a suction side and a discharge side and discharge piping. Your wear rings, these are replaceable rings. They allow some clearance between the impeller and the pump casing, and they do have to be replaced periodically. So to be familiar with those components. And then these last three components here, the stuffing box, the lantern ring, and the mechanical seal. So take a look at this picture, get familiar with them. And not only should you be familiar with these pump components, but you should also be familiar with the general maintenance needs associated with these components. Things like bearing lubrication frequency, checking the seals for leakage, observing the pump for any kind of excessive vibration, understanding your suction and discharge pressures, understanding packing spacing, and impeller placement. So use your study books, get familiar with these components, get familiar with the maintenance of these components. Pretty certain that you will see questions about these on any level 1 or 2 exam. So lots of pictures like this available out there. If you get a chance to be a part of any kind of pump maintenance, take it so that you can see all of these in real life instead of in a picture. It's a great opportunity to really better understand what it is that they're talking about and what you need to be familiar with. All right, guys, a few more slides here on our pumps. When you're operating a pump, you should never start it or run it dry. The water is used to lubricate your parts in your pumps. So if it's dry, it can overheat very quickly and cause all kinds of problems. Cavitation is another issue with centrifugal pumps. Whenever the pump's not running at the designed flow or pressure, cavitation can occur. This is where a vacuum is created and the water vaporizes. And when it returns to a liquid, it's damaging to the pump. It's like little bullets of water shooting your pump parts, and it damages your pump. And one thing to be super familiar with is that a cavitating pump can sound like a can of marbles being shaken. That's why I put this picture here to try and help you remember. Cavitation sounds like marbles shaking in a can. And there are other ways to kind of detect that too, but the sound is really one of the most notable. So what can cause cavitation? When on your suction side, if your pressure is too low, if you're running at high speeds, if you have a clogged suction pipe, you have poor suction conditions, you have a partially closed valve, that's why I said we don't want to throttle valves, or you have poor pipe design, so probably not in a lift station, but in other situations you can have poor pipe design on your suction side. On your discharge side, if the pressure is too high, if the pump's running too far left on the pump curve, if there's clogged discharge pipe, or there's poor pipe design, so maybe your pipe's not sized right, or immediately there's a lot of elbows and T's and reducers, or things like that. It can cause the pressure to increase significantly. So all of those can cause cavitation. The operations of the pump, the net positive suction head, this is another term you should be familiar with. Is your pressure adequate to avoid cavitation? That's what we're talking about. It's the difference in the increase and the influent and effluent pressures. And one way to avoid your net positive suction head being a problem is reducing your flow rate. Air locking, if you get air trapped in your pump, that can be a problem. Also, it's important to note that energy use is the highest during your pump starting because you're using energy to get everything moving. It's like, me as an old lady trying to get out of bed in the morning, it takes more energy than once I'm up and going, right? So you've got to have more energy to get the pump going than any other time. Centrifugal pump curves. So pump performance depends on your flow rate needed and your pressure. So your pump curve is going to show you those things. It's a graph. It has a y-axis and an x-axis, and then there's other things that might be on the graph. And so there's ways to read the centrifugal pump curve. And I do have some handouts that I'll put in the chat as soon as we're done here, so you can see them. They'll also be uploaded on our website. But just being familiar with what's on a pump curve and why you would need one to make sure that you're selecting an efficient, correctly sized pump. And then the last thing about centrifugal pump curves, this one looked really clean and kind of easy to understand, but sometimes they look more like this. This is way more typical. And it can be really confusing, right? But what you're looking at here is head and flow rate, and then you're looking at different impeller diameters and different efficiencies. So understanding how to read a pump curve is an important, just having a general idea of what's on a pump curve and why you would want to understand a pump curve, which is to allow you to select an efficient pump. And I know we're right at time. I hope you can hang with me. I've got one more slide on force mains, and then we've got some practice questions. So we can go through those practice questions. If you can't hang with me, I fully understand. Again, the recording will be available on our website. And I apologize for taking more time than I was allotted. So our lift station force main, this is our last concept of a lift station. This is the discharge pipe of the lift station. So the water comes out of the pump and it goes into the force main. As I mentioned earlier, it is under pressure until the next manhole or a similar opening. So it could be your treatment plant headworks, it could be some other type of opening, but this is where the system would return to gravity or the flow enters the treatment plant. Concerns on force mains, primarily trapped air. It can lead to water hammer, and a water hammer can do all kinds of damage to valves, to pipes, to you name it, right? So oftentimes on our force mains, we will have air release valves. And air release valves are installed at that high point in the pipe to allow the air to escape automatically. And this is just one type of air release valve schematic, but it does let the air out and the water stays in. So that's kind of the the high points of force mains. So I'm going to run through, let's just take a look, if we can, Valeria, at like question 2 to start with. So on your screen, a question should have showed up with a question. So lifting of wastewater in a lift station is accomplished by airlift pumps, centrifugal pumps, piston pumps, or turbine pumps. All right, just another few seconds here. 5, 4, 3, 2, 1. Let's go ahead and end the poll. And if you want to share the results, that'd be great. So everyone answered centrifugal pumps, and that is the correct answer. Let me see here. All right. And then let's take a look maybe. At let's try question 4. So what is the purpose of wear rings in a pump? To hold the shaft in place, to hold the impeller in place, to control the amount of water leaking from discharge to suction side, to prevent oil from getting into the casing of the pump. Just a few more seconds here. 5, 4, 3, 2, 1. All right, if we can end the poll and share the results. So it looks like we've got a fair amount of variety of answers here. So this is good to show that we do need to revisit some of these concepts when you're studying. So the correct answer here is to control the amount of water leaking from discharge to suction side. Okay, so, and I know I kind of covered that quickly, but it is on the slides. It should be in your study materials. So this is why we need to be familiar with the components of a pump and what they do, because questions like this will be on the test. So we want to make sure that you're aware and that you have the tools you need to be able to study and be familiar with those components. For the sake of time, I think I'm going to skip the other questions, but I've got 6 practice questions. I'll put those in the handouts that we share on our website so you can see all of them. But your study books have way more than 6 practice questions. So I encourage you to take a look at that and you know, understand what type of questions you can expect on the test. So last thing is, if you have questions for me, I will stick around and do my best to answer any questions you have. And I'm going to, I was going to try to put the handouts in the chat, but I don't think I can do that while I'm sharing my screen. So I will just put them on the website. I have 2 handouts on pump curves, and I have 2 handouts on pump operations, so that you guys have other resources that you can look at besides your study guides. So thank you all so much for your time, for being here, for participating. I know it's a lot of information, kind of the drinking from a fire hose. If you have questions, if you're uncertain about anything that we presented or anything that's in your study books, we're happy to work with you and answer questions one-on-one. So please let us know. And for those of you that have to jump now, I know we're over time. Again, I appreciate it. If you have questions and want to stick around, happy to do that. So I'll stick around for a couple more minutes, but thank you all. I appreciate your time.